In this short video, I will walk you through a reinforcement learning based framework that highlights the importance of data modeling using knowledge graphs, vector retrieval, use of fine tuned models, reasoning components, and model evaluation, while capturing rewards from actions taken and feeding that experience back into the system. Hi, I am Pavan Mirla, founder and chief AI scientist at Perceptron Solutions. After years of consulting for investment management firms in USA and Canada, I have seen a shift towards experience-based modeling, where decisions are captured, outcomes are evaluated, and the system learns to favor those that lead to better results. By organizing this experience into knowledge graphs and semantic structures, we create a foundation for agents that can reason, adapt, and improve over time. First, let's look at the agents on the screen. The red colored agent is more for operational tasks, designed to follow rules and handle deterministic, repeatable tasks. He's well suited for automation, where the goal is to execute defined processes rather than generate new ones. The plain white agent represents reasoning and generative fine tuned AI models such as LLMs. These agents can generate synthetic data sets, identify causal connections, and support more effective adaptive decision making. Let's assume you are an investment manager receiving data from various sources. For you, the trustworthiness of that data is critical because without reliable inputs, even the most advanced reasoning models won't deliver meaningful results. This step is often overlooked because it feels tedious. But here we assign a trained agent specifically to assist with automation tasks like data reconciliation and accuracy checks. These agents follow clear rules and operate under your control. They listen, they don't improvise. Once we have validated the data, we capture its content in vector embeddings and structure its meaning through knowledge graphs. These two systems, vector databases and knowledge graphs, work together to anchor both raw data and insights. Once we have a tagging system that keeps insights and reasoning close to the data source, that way the lessons learned from past actions and outcomes stay connected, enabling continuous learning over time. In the next stage, this structured data is passed to the reasoning components. Here, we use causal reasoning models that can identify and log cause and effect relationships, run scenario analysis, and perform simulations. These are handled by a mix of general purpose LLM agents and fine tuned agents trained for specific domain, like one specialized in understanding Forex or another focused on fixed income. We also include the predictive models we are already familiar with, whether they are machine learning, deep learning, or statistical in nature. All these reasoning components must work in sync to answer the real question, so what? The data tells us something, but why did this outcome happen? What's the underlying reason? And once we understand that, the next stage is what action should we take? Now comes the most important insight. Humans remain involved in the final action, especially for critical decisions like executing a trade enforcing a policy, or applying a double check mechanism. Before any action is taken, it's essential to verify the trustworthiness and explainability of the predictions or reasoning generated earlier. In this phase, execution agents may interact with external agents. That's where standardized communication protocols come into play, such as MCP, Model Context Protocol, or agent to agent protocols proposed by Anthropic and Google. Tasks can be delegated to other agents, potentially forming an hierarchy where not every agent makes the final decision, but they contribute sub decisions or tool selections. Here's the distinction: deterministic agents follow strict rules and still use MCP, but reasoning agents need the freedom to plan, to choose the right tools, invoke LLMs with relevant context, and return both a reason and explanation along with the model's outcome. These outcomes are then tagged and saved close to the data source, preserving traceability and enabling future learning. Each of these blocks that we discussed could easily be a video on its own. This was just a quick introduction to the opportunities in applying AI to finance. If you have questions or need a sounding board, feel free to email me at office@perceptron.solutions. Note that there is no .com there. I'm always happy to share my thoughts and experiences in implementing AI for finance or AI for asset managers. Thank you.